So welcome to the Ars Electronica Festival 2020. It's a pleasure for me, especially for this session, to introduce our activities and our, say, commitment with a very special organization, the European Space Agency, the ESA. Especially, we are working together with the Earth Observation Area, so the ESRIN department inside the ESA. And we will show you some insights in our activities and projects with them. By the way, I have as well to say that as well the center, the Ars Electronica Center, is a part of the activities as well. There is the ESRO initiative, the European Space Education Resource Center, and the Ars Electronica Center is hosts, so to say, the ESRO Austria Center for educating people in this area of satellite imaging and what all the missions of the ESA is about. For this, we want to show you our cooperation, especially with the ESRIN, and for that I will start with some past activities, and so that we will see the ESA is for us as a long-term cooperation partner. So we started cooperation a long time ago in thinking about what we can do in exchange, in supporting them as well in communication, in installations, in transporting these topics that they address with their satellites. And so we would start our cooperation as well with an exhibition that we have in the center. It was called the Spaceship Earth exhibition, and it was a wonderful exhibition here, running here in the center, more than 3 years, showing really in detail what the ESA is doing with satellites and what we can do as humans in getting this data and using this data in different ways. As well, we have a lot of events together with the ESA. So here you see an example. This was a big event in Prague. It's the Living Planet Symposium. Each 2 years they have this big symposium where, of course, the topic is about the Earth and what we can do to help us humans to ensure the existence of the Earth in a way. And so it was great to be part of that as well. And it leads then in the end to, let's see if I get it, and this is another image, wonderful image of the Spaceship Earth exhibition here in the center. And it leads then in the end to a project that we are going into more detail into that. We called it, together with our colleagues from ESA, the PHI experience. It's about the future missions, and it's a visitor center that we built up in the headquarters of the ESRIN in Frascati, nearby Rome. And I want to introduce as well Mr. Harald Moser. He's a senior project manager and key person as an interface with ESA. And he will show us a little bit about the PHI Experience project and this visitor center that shows really the story of ESA, or better ESRIN, what they do in terms of Earth observation. Harald, please.
Hello. Yeah, it's a pleasure to be able to show you a bit about the genesis of the PHI Experience project. The wonderful thing with our cooperation with ESRIN is that we work together as really partners. So this was the starting point of the project. As you can see it's a lot of content and a lot of activities to be shown inside there. So we started more or less with a blank page, a white room, and the interesting thing was that we could exchange from our knowledge as designers, as interaction designers, as inscenating media to people. We could bring a lot of our experience in, and what is so special about this project is that, as said, we started with a blank project, and there were some thoughts about the architecture also inside. But we could also bring our view of how we would perceive this room onto paper, and our view was also taken in consideration from the architects there. So it was a symbiosis of so to say, strength working together from all the people. So here you can see how we started in the end. And what was super special is that everything built in there, all the materials, all the technologies, everything was like on a very high level in terms of quality. So it's not just all the lights inside. So you have star constellations on the ceiling. You have different light settings for every room. Rupert Huber, a composer and partner of us, composed special soundscapes for every room. We had lights guiding the visitors in every room. And yeah, this was a fantastic project also in terms of the genesis. So here you can see an elevation model, like when it arrived that day in Italy, which we put in. You will see later in detail. And maybe we can show a little bit about, like here you can see the renderings, like the left one is from the architect there. The other one was our view, so to say. Yeah, a lot of machines and computers to be activated in there. And here you can see like how we start to build 10 projects. So we come together, we make the concept, we make the design, and then we start to build up our test setups. So that's a normal process within our projects in Ars Electronica Solutions, that we pre-build everything which is a bit more sophisticated. And here you can see how it was integrated then in Frascati already. And this is how it looked a few days later. So we also worked together with a glass company from Vienna, and they made a really special glass walls for us, which make the whole thing appearing even more sophisticated. Maybe we can take just a quick step and talk about this thing. So this is a special interface we just designed for this exhibition, because for us it was important that we find a very natural way how to interact with global data sets. And so we created an interface which has a glass sphere that is lighting up and shows you the state of can you navigate, can you not navigate, are you looking? And we integrated two special touch screens you can see here. They are not like rectangular shape. We made a very special round shape for that in order to be really integrated in the whole design. And yeah, I think now we are traveling to Frascati and have a look at this exhibition together with our partner Robert Moser from ESRIN.
Yeah, for sure. I mean, you have seen now a lot of insights about the process. It took 1.5 years, so it's a long-term project with a lot of preparation here and then on site in Frascati. And to see what the outcome is, we will now take a journey to Frascati. Our host is Robert Meisner, our friend and colleague from ESRIN. He is leading this facility there, and also the leading person in creating ideas for how to create and really a user experience that show the various different areas where ESA is working on. And so I will, please, can you switch to the...
Maybe just one thing to mention, because it's very important, especially here and also here in the Ars Electronica Center. It's not just ESA, our partner, it's also the German Aerospace Center called Deutsches Luft- und Raumfahrtzentrum, and they are also very important partners in this whole area. We work together.
So let's go to Frascati.
Hello and welcome to the FEE experience of the European Space Agency here in Frascati in Italy. I'm Robert Meisner, and this facility here allows us to show you and to explain to you what we do to build satellites, why we build these satellites, observing our planet, and what these satellite data can contribute to get a better understanding of what's happening on our planet. Now let's start with the basics. The basics meaning we have to build and design and develop these satellites. And in order to do this, we have put together a whole suite of different satellite types, which all have their specific purposes. For example, here is one satellite of the European Union's Copernicus program, biggest satellite program for Earth observation on our planet. And these satellites all have one thing in common: they somehow fly above our planet and look down to measure different parameters. Each satellite is designed in a different way so that it can look at something very specific. Some look at the atmosphere, some look more at land, some look more at oceans. This depends on the technical design. Now, these satellites are all built in a way that they can scan our planet's surface and find out more. Now, after these satellites have been put together, which is a tedious process, it has to be very clean in a clean room, it needs to be very reliable, because once the thing is up there you cannot fix it anymore. But after this has happened, all these satellites, or most of these satellites, are being brought to French Guiana in South America, the European spaceport, where we launch our rockets to bring the satellites into orbit. Satellites are being integrated onto a rocket. In this case, it was a Russian Soyuz launcher, can be an Ariane, can be a Vega. So we have different rockets. And once the satellite has been packed up on top of the rocket, it's being put on the launch pad.
9, 8, 7, 6, 5, 4, 3, 2, 1, top, et décollage.
Once the satellite has been put in orbit, and once it has reached its final position there, it's processing the data on board and it's delivering the data to the ground, where we are analyzing it to get information about the globe. Now, the big advantage of these satellites is that they can always give you a global perspective. They can fly over the poles, the Arctic regions, where it is difficult to do research and to get data. They can fly over deserts or inaccessible areas in the rainforest. They can fly over areas which are not accessible or safe to go to for political reasons. So what we get is a global picture, and this is exactly what we need to get a better understanding of what's happening, for example, to our climate. Now, for example, one data set that we can get from the satellite is a map of nitrogen dioxide concentration. And this nitrogen dioxide concentration allows for the analysis of the air quality. It is an indicator where the population density is high or the pollution density is high, which comes from traffic, which comes from industry, which comes from heating our houses in winter. And it is very diversified over our planet, over Europe. You can see the hotspots like Paris or the Ruhr area in Germany, the Po Valley in Italy. Moving to the east, you see Moscow, and you can also see that air pollution or NO2 levels over China are quite high. Now, this data is relatively closely related to our human activity. And as you are all aware, we have another trace gas we need to look at, and that is carbon dioxide. What you see here is a model of the carbon dioxide distribution over our planet, and you certainly can see one thing: it is very dynamic, it is changing a lot. So the distribution over Earth is always the same, but the concentration is not the same. Looking at the last 800,000 years, I mean 800,000 years is a pretty long time, you see that the CO2 concentration was always in a narrow band between 200 and 300 more or less parts per million. And every time it was high, it was relatively warm on Earth. Every time it was low, it was relatively cold on Earth. A clear correlation between the temperature and this carbon dioxide concentration. Only recently, in the last 50 years, we have seen an increase, and a very steep and a very sudden increase of carbon dioxide concentrations to up over 400 parts per million, which we have not seen in a million years, which is quite amazing. The consequences are known. We have increasing temperatures, we have rising sea levels, and we have melting ice, we have a change in the weather patterns, and we will see more changes in the future. And one of the key results of this is that we are losing a lot of ice, especially in the polar regions. Now here we have a map of Greenland, and what we can do with our satellites is we can look at this very regularly and cover the whole area. And in Greenland we are looking at a map of the ice flow speeds. Ice flow speed is a relatively good indicator for a change in the environment. So faster flowing glaciers usually means warmer weather and decreasing ice thickness. So zooming into this, we see here Jakobshavn Glacier, one of the fastest flowing glaciers in the world, which we can have a look at in more detail by zooming in using a different data set. This is a satellite image of Jakobshavn. Looking at it over many, many years, you see in high detail how much and how the glacier has retreated. We see a retreat of over 20 kilometers in the last 20-25 years of the glacier front. But we also can look at it using radar data, which gives us a different perspective and a different possibility to analyze the data. Specifically, radar data gives us the possibility to calculate the thickness up to the meter or less accuracy. And you see the glacier is going from 0 to 1,500 meters, over 1,500 meters in thickness. And the changes are something we're looking into in detail to get a better understanding. You have to imagine that losing all ice in Greenland would drastically increase our sea levels. This will not happen from one day to the other, but it is a process which has already started. And last not least, we can map, also using these radar satellites, the velocity of the glacier it is flowing at. And the velocity is about 40 meters per day at the calving front, which is a record high speed value for the fact that it is a massive ice mass. So this is one detail we look into. We can also look into other details specifically by using data which we get from our high resolution satellites. And for this we have one more station here which I would like to show to you. What we're looking at is an elevation model covering central Italy, here from the Mediterranean coast all the way up into the Abruzzi Mountains, to the Gran Sasso National Park, covering all the volcanic areas, and projecting onto the surface. We use different satellite data to analyze, for example, looking at areas where we can see a city, where we can detect changes in settlement, but also looking at an infrared image of the same region, which allows us to analyze vegetation in a lot of detail, and which gives us a good background data set to, for example, estimate harvests, but also to look in changes in crop. This is an important topic, looking at food security and looking at long-term planning for agricultural, but also for city life. This concludes my little presentation of the FEE experience. Should you have any questions, please don't hesitate to contact us and let us know if you have suggestions or any other thing to say. Thank you very much for your attention and have a good day.
Cool. So that was, I think, a pretty nice impression that you get now from the visitor center that we have built up together with the ESRIN in Frascati. And I think it's a wonderful experience to go there and to really get this incredible information that is getting from the satellites and transformed into something that we can understand, and we can see how the things are that's going on Earth. And so we have just 2 minutes to go, and so I want to try to get Robert directly here so that we can ask him some question about the future, because what we see here in the image is the planned Sentinel-6 program. So that should be started in this year. So I think in November or something, the satellite should go up. And maybe we get, Harald, could you try to catch Robert on the whereby so that we can ask him directly? Maybe he can, Robert, do you hear me?
Yes, I can hear you loud and clear.
Thank you. So thank you very much for the... this is a feedback. Okay, another try. This is not working. You have to... So this is not really working. Robert, do you... doesn't work. So maybe just a question, Robert. For the Sentinel-6, why is it so important for especially the climate change and all the aspects to it? Can you tell us maybe some words?
Well, what Sentinel-6 is going to do is going to look into the changes in
No, it's not good. So the audio is not working really well. we can try WhatsApp. That will work, I think. No, it doesn't work. So, but anyhow, we have just 1 minute, so it's a pity that... Robert, can you try again? Can you try again?
Can't hear anything in the moment.
So, yeah.
Now you should hear us.
Do you hear us?
Hello?
Yeah, please try to give us some aspects of Sentinel-6.
Well, what Sentinel-6 is all about is the changes in sea level. And the point here is that this is something we have to look into if we want to understand the effects of climate change. And there are 2 reasons for sea level rise. One is obviously the melting of the ice, of the glaciers and the ice in Greenland and Antarctica. But the other one, which is a little bit more surprising, is almost half of the sea level rise comes from an increase in temperature of the water in the oceans,
because the water gets warmer, so it's expanding. There's nowhere to go, so it's rising. So we've been looking at this for over almost 30 years now with satellites. And satellites are actually really the only way to measure the changes in sea level because, surprisingly, they're not the same everywhere. In average, we see 3 millimeters of sea level rise over the last 28, 29 years. It's increasing, it's going up to 5 millimeters in recent years per year. This may not sound a lot, but by 2100, sea level could rise as much as up to over 1 meter. And that's something our grandchildren are going to see. And this is a threat, and this is a challenge, and we need to understand better what we can do. And for this, we need very long data time series. And this is what Sentinel-6 is looking into. There is an older fleet of satellites which has been flying and partly still is flying called JASON, American-French project. And we are contributing this with Sentinel-6. We're going to continue the series, and we're also going to increase the resolution of the data so we get a higher quality of the data in the future.
Thank you very much, Robert. I think this is great. We have to close this session for the next one. Thank you again for your commitment and that you were able to be live here on stage with us. Have a nice weekend. We see us soon. For here, I have to close the session. I hope it gives you some aspects what we can do with satellite data and what we are trying to transport as well in different installations and exhibitions to go for this topic, because I think it's really a really important one for us humans. So thank you very much for your attention. And maybe Harry?
Yeah, maybe last but not least, a side note, because we saw so many wonderful and inspirational data sets which we have to deal with as a human race. You have the possibility to go downstairs in the Compass exhibition. There is a special area called Global Shift where you can see a lot of this data we worked on together with the ESA. There is a few exhibits you can experience downstairs.
Mm-hmm. Thank you. Thank you.
Thank you.